Okay, so for number 8, looks like the range is good. The range is 192. So we have to cover a distance of 192 within the data and within our 10 classes. So once we get the range, the next thing we want to do is divide it by 10 to figure out roughly how big each class should be. So we get a class width of 19.2, but that's a pretty ugly number. If we made every class 19.2, it would become pretty messy pretty quickly. So we want to round that. We can't round it down because if we round it down, we might not cover enough distance to include all of our data points. So we have to round it up every single time. And we're going to round it up to the next quote unquote nice class width. So this is kind of subjective on the computer's part, but whatever you get when you divide by 10, round it up to the next quote unquote nice number. Nice numbers are like multiples of 10 or 20 or 50 or 100, something like that. So this is going to round up to 20. So that's going to be the optimum class size for this data. So we will put 20 there. Okay, so you're going to divide by the number of classes and then round up to the next quote unquote nice number. What's nice is really what you consider nice is up to you, but the computer likes 10, 20, 50, and 100 and so on. Okay, following stem and leaf plot, find the 5-number summary for the data. So the first thing we want to do whenever we're finding the quartiles is to start by finding the median. So let's figure out how many data values are there here. Sometimes it might be easier just to list out the data values. Like we have this 0 denotes a 10, a 12, 23. You could do that, but let's try and do it without having to copy all the data again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 data values. So the median is the middle value, but since there's an even number of things, there is no middle value. So the middle is going to lie between two data values. We're going to have 9 values. Whoops, sorry about that. Our median, and then 9 more values, making the total 18. So our median is going to fall between the first 9 values and the last 9 values. So if I count up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 47 is the 9th value. 49 is the 10th value. So my median is going to be between those two numbers. See, I have 1, 2, 3, 4. I have 9 things in front and I have 9 things behind that orange line. So whatever that orange line is going to be my median. So when it's between two values, I take the average of those two values. So it's going to be the average of 47 and 49, which is going to give me 48. So my median is going to be 48. Now to get the Q1, I just repeat that process again with the first half of the data, with those first 9 values. So I'm finding the median of those 9 values. And since there's 9, there will now, in fact, be a middle value. There will be 4 values, my median, and then 4 more values, totaling the 9 values total. So it's going to be the 5th value in the first half of the data. So I'm going to go 1, 2, 3, 4, 5. So your medians can either be between two values or an actual value itself. So notice I have 1, 2, 3, 4 things in front of this box and 1, 2, 3, 4 things behind this box. So my Q1 is going to be 24. If you do the same thing with the second half, it's going to be the middle value of the last 9. 1, 2, 3, 4, 5. It's going to be this. That's where you get the 58. 4 things in front, 4 things behind. The visual makes much more sense when they're listed out in a line, but hopefully you can still see when it's written as a stem and leaf plot like that. Okay, approximate the mean for the following group frequency distribution tables. So this is kind of a tedious exercise because we have to use the calculator and all that. But so it's telling us we have 1 value between 30 and 34, 3 values between 35 and 39, 8 values between 40 and 44, Problem is we don't know what those 8 values are. So when we're doing this, we just assume that every one of these 8 values is the absolute middle of this class. So all 8 of these values are going to be 42s. All 3 of these values are going to be 37s. This value is going to be a 32. So I'm going to do that for each class. I'm going to take the value that we're letting each of them be. So in the first case, I said it's going to be 32, and I'm going to times that by 1 because there's one of them in that range, plus 3 times 37, plus 8 times 42, plus 14 times, these are all going to be 47, plus 16 times 52, plus 12 times, those are all going to be 57s, plus 9 times 62, plus 4 times 67, plus 1 times 72. So I get 3,551. But I have to divide that by the number of data values in my data set. So I have to divide that by whatever all these are added up. 1 plus 3 plus 8 plus 68. So I'm going to do 3,551 divided by 68. Oops, not times. Divided by 68. I get 52.2. So we can probably just round this to 52. Okay. It's a little painstaking, but that's the process involved. Adding up all the value. The key here is just knowing that you let each value in the range be the absolute middle of the range of the data, the class, because we don't know what any of them are. Okay. And the last one says, here's a data set with 117 data values, and they've been sorted, luckily. It'd be a pain if they weren't. It says, find P3, the value of the locator. Okay, so when you see P with a sub number here, that's the percentile. So this is going to be the third percentile. It's kind of a weird one. It's a very low percentile to look for, but that's the third percentile. So that's the number or the value that cuts off the bottom 3%. So I have to figure out how many of these boxes make up 3% of the data. Well, there's 117 boxes. If I multiply that by 3%, I get 3.51. So whatever you get, it's safe to assume you round up to make sure that you actually cut off the bottom 3%. So we're going to round this up to the next whole number, which would be 4. So the fourth box is going to be my third percentile, which is a weird way of saying it. But the fourth box will cut off the bottom 3% of the data. So this will be 4. So it says use the locator to give the value of the third or the 3 percentile or third percentile. So it's just going to be the value in the fourth box, 58.6. Now, just to make this make a little bit more sense, because I don't like these numbers. If I said something like find P of 60, that would be the 60th percentile. So I figure out which box cuts off the bottom 60%. So I would do 117 times 60%, and that would be 70.2. I'd round that up. So the 71st box would cut off the bottom 60%. So this would be 71. And then you'd have the joy of counting up 71 boxes, and whatever that box is, I don't know, somewhere in here, whatever the 71st box is, once you count them up, whatever's in that box, that would go in the second answer box right there. Okay, it's weird how they chose third or 3 percentile.